All right, here's the first work energy problem, the first example problem. We're going to be following the problem solving strategy for work energy problems that is posted online. We're going to start with the sketch and translate. All right, so a skier slides down an icy hill. He has a mass of 70 kilograms and begins 50 meters above the bottom of the hill. Okay, we have sketched the initial picture and the final picture. We see the skier at the top of the hill, and then we're looking at them 3/4 of the way down. All right. They are asking for the kinetic energy of the skier on the way down. So at least in our system, we should have the skier. So when we have our system here, we should at least have the skier. Okay, and if we want to include gravitational potential energy, we need to include the Earth. Okay, if you want to do work by the Earth, that's fine, but that has to be separate. Now, oops. Moving forward here, this would be our initial state. 3/4 of the way down the hill would be our final state. All right, things we can simplify. Since they're skiing, it's an icy hill, we can assume that there's no friction. All right, no friction involved, so there's going to be no work done by any external forces. All right, now we are going to construct a work energy bar chart here. So looking at this, we're going to have the initial state, we're going to have the kinetic energy of the skier at the start, plus the gravitational potential energy plus the work will equal the kinetic energy at the end plus the gravitational potential energy at the end. It's not the straightest line. Let's try that again. There we go. All right, so initially they are not moving. We know they have kinetic energy 3/4 of the way down, so they're moving, but we do not know at what rate. So if we look at this, at the beginning, we're going to have all types of gravitational potential energy and no kinetic energy because the object is not moving. Basically, is the object moving? If the answer is no, no kinetic energy. Is there a height above the zero reference frame? Okay, the zero reference frame I am assuming here is the ground. So UG at the ground is equal to 0, which means we have 50 meters above that, so this is why there is a bar of gravitational potential energy. There's no friction involved. We're going to assume air resistance does not exist. Okay, so there will be no work done by any outside forces. Now, they travel 3/4 of the way down the hill, so the gravitational potential energy is going to become smaller by 3/4. So, which means there'll be a quarter left over. Now, the rest of that gravitational potential energy has been transformed into kinetic energy. So the rest of that bar goes here. Now we have gravitational potential energy. So our bar chart is now complete. It's kind of consistent. This is the largest bar, and these two added together should equal the original. All right, so UGI is equal to KF plus UGF. All right, now we can solve for either of our two questions. What is the kinetic energy when he's 3/4 of the way down the hill, and how fast is a skier traveling when they are 3/4 of the way down the hill? So earlier in class today, we derived an expression for gravitational potential energy, which is mgyi is equal to, they're asking for the kinetic energy, so I'm just going to leave kinetic energy by itself. Don't have to solve for the speed yet. I can just solve for kf. That would tell me the amount of kinetic energy, plus mgyf. Well, if I just want to know the amount at that point, I can subtract mgyf from both sides, so I'm left with mgyi minus mgyf. All right, now to kind of figure out the height at 3/4 of the way down the hill. So if we look at this and we figure out, if we take 50 meters and we divide it by 4, we find that that is equal to 12.5 meters, which means there's 12.5 meters of height to go to get to the bottom of the hill, and the skier has dropped 37.5 meters. Okay, so our initial height here would be 50, so this is going to be the mass times 10. So 70 kilograms times 10 newtons per kilogram times 50 meters. Okay, and I'm going to combine these two terms. Actually, never mind. Minus 70 kilograms times 10 newtons per kilograms times 12.5 meters. All right, now if I substitute all the numbers in and solve for the amount of kinetic energy, I should get 26,250 joules. All right, that is my kinetic energy. Now they're asking for the speed. Well, we know kinetic energy is also equal to 1/2 mv squared. Okay, so I can solve for v by multiplying through by 2 and dividing by m. So we get, if we do the algebra, we get 2 times the kinetic energy divided by the mass is equal to v squared. And then take the square root on both sides. So we get 2 times 26,250 joules divided by the mass of the skier, which is 70 kilograms. And we find out that our speed at the bottom of the hill, or the skier skis at the bottom of the hill, is 27.4 meters per second. Okay. All right, that right there is how you set up and solve a work energy problem.